되게 달콤한 그만 아이스크림 케이크 특별해진 오늘의 어울리는 맛으로
Assalamualaikum warahmatullahi wabarakatuh. Today I want to explain you about integration partial fraction. When and why do we use partial fraction? First, can only be done if the degree of the numerator is strictly less than degree of the denominator. Second, a rational function whose numerator has higher degree than denominator divide and write the form of, and usually we have the px over qx, and this is we have the hasil bagi, and then r is remainder or sisa, and over qx it is pembagi or quotient or divided. For each factor in the denominator, we can determine which method you should use for the partial fraction decomposition. And this is, we have the four methods. First, if we have the integral of px over gx with degree px, it is equal to degree qx minus 1. And the second, if we have the degree px, it is less than qx, and qx is reducible. And then if we have the px less than qx, but qx is not reducible, and if we have the px more than equal to degree qx. So let's see the example. In here we have the first method. The first method in here we have the degree px, it is equal to degree qx minus 1. So in here we can use the substitution, use u it is equal to qx, and try to find u. And usually it is same with the substitution method. And let's see the example in here. Let's see, we have the 3, and here we have the degree px, it is equal to 0, and in here we have the degree of qx, we have the x in here, it means that we have the degree 1, but it is minus 1, so it means that it is have the degree 0 and 0, right? So let's see, in here we can use the substitution method. First we must let u it is equal to mx plus 1, and then we can derivative this function, so we can get the du over dx it is equal to 5, and then we can make the only dx it is equal to du over 5. And then as the substitution method, we can use the integrals of 3 over 5x plus 1 is equal to u, and dx it is equal to du over 5. So we can get the 3 and 5 as the constant number, so we can make it front of the integral, and we can only have the 1 over u du. So in here with using basic integration formula, if we have the 1 over u, it is same with ln u. And then back to and substitute again what is u, it is have or equal to 5x plus 1. So we can get the 3 over 5 ln 5x plus 1 plus c. And then for the second example, in here we have the x, and x in here we have the degree 1, and we can see it is the highest degree is 2, but in here 2 degree q is 2, minus 1 is equal to 1, and degree p is equal to 1. So we can make with use substitution method again, and in here we can make the let u it is equal to x squared minus 3x plus 1, and then as usually you can derivative this function, so we can get du over dx and 2x minus 3, and then make it dx it is equal to du over 2x minus 3. And then in here we can substitute in the quotient. The first is 2x minus 3 is equal to 2x minus 3 over, and it is equal to u, right? And then we can take u in here, and then dx is equal to du over 2x minus 3. So in here we can eliminate 2x minus 3 and 2x minus 3 in here, so we can only the integrals of 1 over u du, and then we can use basic integration formula, so we can get the integrals of 1 over u, it is equal to ln u, and then back to substitute u as the x squared minus 3x plus 1, so we can get this result.
매일 다양하게 보여줄게 너에게